A pair of bean-shaped organs, the kidneys, are situated at the rear of the abdominal cavity, in the retroperitoneal space. Inside the kidneys are located an outer region, the renal cortex, and an inner region, the renal medulla. The kidneys perform 4 main functions: excretory functions, regulatory functions, endocrine functions, and metabolic functions. First is the excretory functions. Excretory functions include excretion or removing metabolic waste products eliminated in urine, like urea, which is the waste from protein metabolism, creatinine from muscle metabolism, uric acid from the breakdown of nucleic acids, bilirubin from the breakdown of hemoglobin, and some foreign substances, such as drugs and toxins. In order to understand the functional capability of the kidneys in clinical practice, doctors must examine the urea and creatinine levels of the blood. In a condition of dehydration and a person is hypoglycemic, the doctor may detect increased level of urea in the blood, which is called a uremia, whereas the creatinine level remains normal. The reason for this, as stated in popular medical textbooks, is that there is usually increased reabsorption of urea by the kidneys. Again, uremia does not tell whether the kidneys is working properly. Therefore, blood creatinine level is the generally accepted standard to determine the excretory functions of the kidneys. The second function of the kidneys are the regulatory functions. First, the kidneys regulate the balance of water. This means when someone drinks more water will be removed from the body, while when less water is consumed, the kidneys retain more water in the body, preventing dehydration. The second regulatory function is the control of electrolytes balances such as sodium, potassium, chloride, bicarbonate, calcium, and of course acid-based balance as well. For the endocrine functions of the kidneys, the first hormone secreted by the kidneys is erythropoietin. This hormone is secreted by epithelial cells in special capillary bed. It is important to understand that erythropoietin controls erythropoiesis, or red blood cells production, in the bone marrow. These cells are very sensitive to oxygen level in the blood and the hypoxic condition. These cells produce more erythropoietin for facilitating erythropoiesis. The second endocrine function of the kidneys is activating vitamin D. First, the parathyroid hormone acts on the proximal convoluted tubule cells, and then hydroxyl aids 25-hydroxy vitamin D to form the active form of vitamin D. Vitamin D can act on kidney, intestines, and bones to regulate calcium homeostasis. The third endocrine function of the kidneys is renin secretion. This enzyme is produced by juxtaglomerular cells. The juxtaglomerular cells are specialized smooth muscle cells mainly in the walls of the afferent arteriole and some in the different arterioles that deliver blood to the glomerulus. Renin regulates blood volume, blood pressure, and electrolyte balance. Finally, the fourth endocrine function of the kidney is the secretion of prostaglandins. Prostaglandins are dilators that serve to contract primarily angiotensin to mediate ways of construction acting at the level of the arterioles and glomerular mesangial cells. During a state of stress, the increase in sympathetic tone causes vasoconstriction of the afferent arterioles. The same stimuli activate a local production of prostaglandins. Prostaglandins lead to ways of dilation of the afferent arterioles that's modulating the ways of construction. The long use of such medication like nonsteroidal anti-inflammatory drugs can block the synthesis of prostaglandins, leading to constriction afferent arterioles, decreasing renal plasma flow, which in turn decreases glomerular filtration. This may result in acute renal failure. And finally, there's the metabolic function of the kidneys. The first very important metabolic function of the kidneys is ammoniogenesis, which has an important role to play in acid-based homeostasis. Also during starvation, the kidneys has the ability to produce glucose through the process called gluconeogenesis.